So here, two particles move in a uniform gravitational field with an acceleration g. At the initial moment, the particles were located at one point and they moved with velocities v1 3 meter per second and v2 4 meter per second horizontally in opposite directions. Let us suppose that there is a building like this. Two particles start moving in two opposite directions. This is 3 meter per second. For other particle, this is let's say 4 meter per second. These two particles moved with speed v1 is equal to 3 meter per second and v2 is equal to 4 meter per second horizontally in opposite directions. That is in plus x and is in minus x direction. Let it be plus x. Let it be minus x direction. Find the distance between the particles at the moment when their velocity vectors become perpendicular to each other. This is A, this is B. तो जब इन दोनों पार्टिकल्स के वेलोसिटी वेक्टर्स यानी VA वेक्टर और दूसरे वाले पार्टिकल का वेलोसिटी वेक्टर यानी VB वेक्टर, जब ये दोनों वेलोसिटी वेक्टर परपेंडिकुलर हो जाते हैं तो व्हाट वी हैव टू फाइंड इज वी हैव टू फाइंड डिस्टेंस बिटवीन A एंड B. Distance between A and B. So ऐसा करने के लिए we have to first find the time when velocity becomes perpendicular. Time when velocity becomes perpendicular. और उस time को कैलकुलेट करने के बाद we will see कि how we'll find the distance. तो time at which velocity becomes perpendicular can be easily found using the concept of vector products. Let me write the velocity of particle B in vector form. I know that the velocity of particle B in vector form is minus 3 I cap, and obviously gravity will increase its velocity per second in y direction by v is equal to u plus at, right? So Vy is equal to Uy initially was 0 plus A in y direction is g, and in time t the velocity in y direction by a particle A or by particle B both will be gt in downward direction. So it becomes minus gt. Similarly, if we talk of particle A, then for particle A its velocity is Vi 4 I cap, and obviously plus minus gt in j cap. So velocity of particle A is 4 I cap minus gt j cap. Now we know from vectors that whenever two particles whenever two vectors are perpendicular, then their dot product is 0. For two mutually perpendicular vectors, their dot product is 0. So here we can also say that VA vector dot VB vector will be 0. So it is 4I minus GT j cap dot product with minus 3I minus GT j cap. While solving we get 4 gets multiplied with minus 3, so this is minus 12 and plus G square T square is equal to 0. So T is equal to 12 by G square and whole under root, so root 12 by G. So this is the time when these two particles become perpendicular in velocities. Now we can easily understand that gravity is taking both particles A and B equally in downward direction. The displacement of particle A in downward direction is simply half gt square, and displacement of particle B in downward direction will also be half gt square. So whenever we can easily say that these two particles, because they are projected at the same time, ये पार्टिकल दोनों हमेशा सेम लेवल पे रहने वाले हैं. बस जो इनके बीच की x दूरी है, x डिस्टेंस है, दैट विल कीप ऑन इंक्रीजिंग, क्योंकि ग्रेविटी दोनों को बराबर नीचे लेकर के आ रही है हाफ जी टी स्क्वायर टाइम t के अंदर. तो इनके बीच की जो दूरी होने वाली है वो सिर्फ x डायरेक्शन में इंक्रीज होगी. तो इनके बीच की जो दूरी होगी s relative that will be only in x direction and that can be easily given by वो आगे चल रहा है 3 की एक चल रहा है 3 की वेलोसिटी से पीछे, एक चल रहा है 4 की वेलोसिटी से आगे, तो टोटल वेलोसिटी हो गई दोनों के मिलाकर के 7 और टाइम कितना लग रहा है √12 by g. So the relative distance between these two particles when their velocities become perpendicular is this, which is almost equal to 2.5 meter on an average. So this is the final answer.